there folks, Slammin' Sammy Systems here, talking to you about solving systems of linear inequalities. Now I got a question. Why did the baseball player feel so funky? Cause he was standing on the baseline! A boo 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 bow!
Now to start with example 1, it says, is the ordered pair -1, 1 a solution to the system below? So here we have a system of inequalities, that's just two or more inequalities, and we have to figure out, is this ordered pair a solution to this system of inequalities? Well, the first thing you're going to do is take our point, -1, 1, and we're going to plug it into the first inequality. So I'm going to take -1, plug it in for x, 1, plug it in for y. Now I simplify each side. What's 2 times -1? That's -2, and -2 minus 2 gives you -4. Once you get both sides simplified, you then ask yourself, is this remaining inequality true? Is 1 greater than or equal to -4? Yes, it is. Therefore, -1, 1 is a solution to the first inequality. But is it a solution to the system? It has to be a solution to the second inequality as well. So we take -1, 1 and plug it into the second inequality. So I take -1, plug it in for x, 1, plug it in for y. Now I simplify. What is -1 plus 1? That's 0. Now we've simplified both sides, so we ask ourselves, is this remaining inequality true? Yes, 0 is greater than or equal to 0. So we are good. This checks out. Because this point is a solution to both of these inequalities, you can say that -1, 1 is a solution to the system of inequalities. And you're done.
Baseball, 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 you try!
Okay, let's do this one now. Again, you're going to take the point and you're going to plug it into the first inequality. So we take -2, plug it in for x, 4, plug it in for y. Now I simplify. What is 2 times -2? That's -4. And what is -4 minus 2? That's -6. Now we've simplified both sides, so we ask ourselves, is this remaining inequality true? Is 4 greater than -6? Yes, it is. Therefore, this -2, 4 is a solution to the first inequality. But is it a solution to the second inequality as well? Well, we need to take this point and plug it into the second inequality. There is no x, so I don't plug in -2 anywhere. I just plug in 4, because that's the y value. So I take 4, plug it in for y, and then I ask myself, is this inequality true? Is 4 less than or equal to 3? No, it is not. Because this point is not a solution to this inequality, you cannot consider it a solution to the system of inequalities. So -2, 4 would not be a solution to the given system. It is a solution to the first inequality, just not both inequalities. Now example 2 says graph the solution to the given system. So here we have another system of inequalities, and this time we're graphing our solution. So in order to graph the solution, all we do is we graph both of these inequalities on the same coordinate plane, and wherever the shading crosses, that is going to be your solution set. That's going to be all the ordered pairs that make both of these inequalities true. So let's start. We're going to graph the first inequality. We first ask ourselves, is this in slope-intercept form? Y mx plus b. Yes, it is in slope-intercept form. Perfect. Next, we're going to plot 3 points. So in order to plot 3 points, since it's in slope-intercept form, we start with our y-intercept. That would be -5 here. So we go to our y-axis down to 0, -5, and we put a point. Now, notice it's an open circle. Why is that? It's because there is no equal sign under here, which means when we graph this line, it's going to be a dashed line, meaning that no points on the line will make this inequality true. None of the points on the line are part of the solution to this inequality. So we need to keep them open circles and a dashed line to show that. So we started with our y-intercept, and now what's our slope? We're going to use our slope to get the rest of this dashed line. So it's 1. We write that as a fraction, 1 over 1. So from this open circle, we go up 1, right 1, put an open circle. Up 1, right 1, put an open circle. We plotted 3 points. We now ask ourselves, is this a solid or dashed line? Since there is no equal sign under here, it's obviously going to be a dashed line. So we draw a dashed line going through those points. Now, normally you'd be done, except this is a linear inequality. Now, because of this inequality, we now have to shade. Do we shade above our line or below our line? Well, is the inequality facing away from the y or eating the y? If it's eating the y, we shade above. If it's facing away, like this one, we're going to shade below. So we want all the y values less than x minus 5. So we shade below this given line. Sweet, now we have successfully graphed this first linear inequality. Let's graph the second one now. So is it in slope-intercept form? Y mx plus b. Yes, we are in slope-intercept form. Check. Next, we need to plot 3 points. Now, because there's an equal sign here, we can plot closed circles instead of open circles like this one. So we start with our y-intercept. That would be 1. So we go to 0, 1, put a closed circle, and use our slope to get the rest of the line. What is our slope? -1. How do I write that as a fraction? -1 over 1. So I go down 1, right 1, put a point. Down 1, right 1, put a point. I've plotted 3 points. I decide, is my line solid or dashed? Because there's an equal sign underneath, we can put closed circles and a solid line going through those closed circles. That means that every point on this line will make this inequality true. We then have to ask ourselves, because it's a linear inequality, do we shade above our line or below our line? Well, since, again, the inequality symbol is facing away from our y value, not eating it, we're going to shade below, because we want all the y values less than or equal to -x plus 1. So less than, we want all the y values below this given line. Now, you can see that the 2 shades cross in this purple region right here. That is called our solution set. And what that means is that any point in this purple region and on this solid line, not on this dashed line, would cause both inequalities come out true. If you were to plug in any point here for x and y in both of these inequalities, they would both come out true. So that's why this is the solution set. And again, on your piece of paper, I would just shade this in a little bit darker to show that these aren't part of your solution set, but this is your solution set.
Take me out to the U-turn.
Okay, doing the same thing here. First, is it in slope-intercept form? Yes, it is. Y mx plus b. Yes, we are in slope-intercept form. Next, plot 3 points. So our b value is what we start with. That's our y-intercept. So at 0, -3, we are going to put a open circle. Why an open circle? Because there's no equal sign under here. We have to show that the line is not part of the solution set. So we put an open circle at 0, -3, and we're going to use the slope to graph the rest of the line. What's our slope? 2. So we write that as a fraction 2 over 1. So from this open circle, we go up 2, right 1, put an open circle, up 2, right 1, put an open circle. Sweet, we plotted 3 points. Now we need to decide, is it a solid or dashed line? Well, we already said we're using open circles, therefore it's got to be a dashed line because there's no equal sign under here. That means the line is not going to be part of your solution set. Next, are we going to shade above or below? Because it's a linear inequality, we need to shade. And since we have an inequality symbol that is eating the y, we're going to shade above our given line. Again, we want all the y values greater than 2x minus 3, so we want all the y values above our given line. Sweet, let's do the second one now. We have y is less than or equal to -2x. Is it in slope-intercept form? Y mx plus b. Yeah, b is just 0 because it's not there. So yes, it's in slope-intercept form. So we're going to plot 3 points. We start with our y-intercept, which in this case is 0 because it's not there. So at 0, 0, we're going to put a closed circle because this equal sign is here, which means that the line that we graph is going to be part of the solution set. So we have to denote that by using closed circles. And then we use our slope to get the rest of the line. So -2, we write that as a fraction -2 over 1. So we go down 2, right 1, put a point, down 2, right 1, put a point. Now we draw a solid or dashed line. Well, since there's an equal sign, it's going to be a solid line going through those 3 points. And do we shade above or below? Well, our inequality symbol is facing away from the y, so we're going to shade below this given line because we want all the y values less than or equal to -2x. Again, your solution set is going to be wherever the 2 shades cross. That would be this purple region right here, so shade that in a little bit darker, and all points in this solution set will cause both of these inequalities to be true if you were to plug them in. Okay, example 3, doing the exact same thing. We want to graph the solution to this system on here, and then where the shadings cross, that's going to be your solution set. So let's start by graphing this first linear inequality. We want to first determine, is this in slope-intercept form? And if it's not, we're going to put it in slope-intercept form. So y equals mx plus b? No, it is not in that form. Therefore, we need to put it in that form. So we need to get y by itself over here. So to do that, we need this -x to go to the other side. How do we do that? Well, what's the opposite? The inverse of -x, that's +x. So we got to add x to both sides. That way, these are going to cancel each other out. And over here, instead of writing 4 plus x, we want to put it in slope-intercept form, which is again y equals mx plus b. So the mx has to go first, and then we'll add the 4 to the end. Now we have it in slope-intercept form, where our m is 1 and our b is 4. So from there, we can plot our 3 points. What are our 3 points? How do we do this? Well, again, we start with the y-intercept. Y equals mx plus b. This plus b, that's your y-intercept. So that would be 4. That means at 0, 4, we're going to put a point. That is the y-intercept of this linear inequality. Next, we need to use the slope to graph the rest of the line. What's the slope? 1. How do I write that as a fraction? That'll be 1 over 1. So that's your rise over run. So we go up 1, right 1, put a point. Up 1, right 1, put a point. Now we have successfully graphed our 3 points, and I want you to notice that they are closed circles, right? They are not open circles, and that is because we have an equal sign under here. Now what else does that equal sign tell us? It tells us that we're going to have a solid line. So anytime you're using closed circles, you're going to have a solid line going through those 3 points. That means any point on this line will cause this inequality to be true. Next, we can decide, are we shading above or below this given line? Look at the inequality symbol. Since it's facing away from the y, we're going to shade below. And it makes sense, right? We want all the y's less than or equal to this line, so we're going to shade below this line, all the y values less than this line. Next, we're going to graph our second linear inequality. So first, is it in slope-intercept form? Y equals mx plus b? No, this is in standard form. So we need to get y by itself. How do we solve for y? We get this 3x to the other side. To do that, we subtract 3x from both sides. That way these cancel out, and over here, again, instead of writing 1 minus 3x, I'm going to write negative 3x plus 1. It means the exact same thing, but now it's in slope-intercept form, where it's going to be easy to graph. So let's plot our 3 points. What's our y-intercept? That would be this b right here, this plus 1. So at 0, 1, we're going to put a point. Okay, and is it going to be an open or closed circle? Well, since we have an equal sign down here, it's going to be a closed circle. Now again, we're going to use our slope to get the rest of this line. Our slope in this case, right, y equals mx plus b. So m is our slope, negative 3. And you write that as a fraction, negative 3 over 1. That tells you your rise over run. So we're going to go down 1, 2, 3, right 1, put a point. Down 1, 2, 3, right 1, put a point. And again, since we have an equal sign down here, when we decide solid or dashed line, it's obviously going to be a solid line. And then we decide, are we shading above or below this given line? Well, since the inequality symbol is eating the y, we want all the y values greater than this line. So we're going to shade above this line. Now, you can see that the 2 shades cross in this purple region right here. That is called our solution set. That means that any point in this region would cause both of these inequalities to be true if you were to plug them in. Again, because we have solid lines, that means any points on this portion of the blue line and this portion of the red line would also cause both inequalities to come out true. They are part of your solution set.
What does a baseball team and a pancake have in common? They both need a good batter. Boom, boom, boom. You try.
Okay, so here, again, we want to graph both of these on the same coordinate plane. When we graph our first one, we have to decide, is it in slope-intercept form? Y equals mx plus b. Well, it's really close, right? Y and then mx plus b. We got to get rid of this 2, though. How do we get rid of that 2? Well, it's 2 times y. So to move that to the other side, I have to do the opposite, the inverse. I divide both sides by 2. And when I divide over here, I divide each term by 2, the x and the 6. So this becomes, when the 2's cancel out here, y is greater than or equal to, and then you could write this as x over 2 or 1/2 x means the same thing, plus, and then 6 divided by 2 is 3. And you have your linear inequality in slope-intercept form. Now let's graph it. So in order to plot our 3 points, we start with our y-intercept. That would be this plus 3. So we go up to 0, 3 on our y-axis. And are we going to put a closed or open circle? Well, since we have an equal sign right here, we're going to put a closed circle at 0, 3. And we're going to use our slope to get the rest of the line. So since this is in y equals mx plus b form, m is our slope, this 1/2. That tells you your rise over run. So we're going to go up 1, right 1, 2, put a point. Up 1, right 1, 2, put a point. We have our 3 points. We can then decide, are we going to have a solid or dashed line? Again, we have this equal sign down here, which tells us that we have solid points and we have a solid line that we're going to graph through those points. This tells us that every point on this line would cause this inequality to be true if you were to plug in the x and the y. Next, are we going to shade above or below this line? Well, since the inequality symbol is eating the y, we want all the y values greater than this line, so we're going to shade above this given line. Next, let's graph the other one. So here we have 4x plus y is greater than 0. Again, we want it in slope-intercept form. Y equals mx plus b. This is in standard form. So we need to get this 4x to the other side. Since it's positive 4x, I'm going to subtract 4x from both sides. When I do that, these are going to cancel each other out. And over here, 0 minus 4x is going to be negative 4x. So we have y is greater than negative 4x. And it's in slope-intercept form, where our m is negative 4 and our b is 0. Next, let's plot our 3 points. So we start with our y-intercept. Since there's nothing here, that means our y-intercept is 0. So we're going to put a point at 0, 0. Now, is it an open or closed circle? Well, since there's no equal sign down here, it's going to be an open circle at 0, 0. That means that this point is not part of our solution set. We can then graph the rest of the line using our slope. So our slope is -4. We write that as a fraction -4 over 1. That's your rise over run. So we go down 1, 2, 3, 4, right 1, put an open circle. Down 1, 2, 3, 4, right 1, put an open circle. We have our 3 points. We can then decide, are we going to have a solid or dashed line? Since there is no equal sign here, we have a dashed line. That again indicates that the points on this line would not make this inequality true. Next, are we going to shade above or below this line? Since our inequality symbol is eating our y, that means we want all the y values greater than our line, so we're going to shade above this given line. Now, you know your solution set is the place where the 2 shades cross, so this purple region right here would be your solution set. That means that any point in this region, if you were to pick it and plug in that x value for both of these x's and that y value for both of these y's, would cause both of these inequalities to come out true. And when you're looking at the boundaries of this solution set, you can see that this is a solid line, meaning that any point on this line would be included in your solution set. But any point on this line, this dashed line, would not be considered part of your solution set because it would cause one of your inequalities to not be true. Now, example 4, doing the same thing. We'll start with our first linear inequality, and here, is it in slope-intercept form? Well, there is no y, right? So you can't put it in y equals mx plus b form. Instead, it's just x is greater than 2. Okay, that's interesting. So we'll skip this step for now. We don't need slope-intercept form if there's no y. Next, we're going to plot our 3 points. Well, we're going to plot the points for the line x equals 2, and then we'll decide which way to shade, okay? So when we plot our 3 points, do we have open circles or closed circles? Well, since there's no equal sign down here, they're going to be open circles. So we go over to x equals 2. Remember, that is the equation of a vertical line, right? X equals a number is a vertical line. So at 2, 0, we're going to put a circle. That's one of our points. And then we go 2, 1 and 2, 2. Those would be 3 points on the equation of the vertical line x equals 2. So then we can decide, do we have a solid or dashed line here? Well, since we had open circles, that means there's no equal sign under here. That means it's a dashed line. So we put a dashed line going through those points. That means that any point on this line would not cause this inequality to be true. That's why it's a dashed line. Next, which way are we going to shade? Right or left? Well, it's x is greater than 2. So we want all the x values greater than 2. So that would be 3, 4, 5, 6. So we're going to shade to the right. Next, we have y is less than or equal to -3. So now we have to decide, is this in slope-intercept form? Y equals mx plus b. Yeah, there's just no x. Next, plot 3 points. Again, since you have y equals a number this time, that means that you're going to graph a horizontal line. Y equals -3. So we go to -3 on our y-axis. And because it's an equal sign underneath, that means we're going to put closed circles for our points. So we put a point at 0, -3, 1, -3, 2, -3. Sure. Then we put a line going through those. Is that line going to be solid or dashed? Again, there's an equal sign under here, so it's going to be a solid line going through those points. And we decide, are we shading above or below? Well, since our inequality symbol is facing away from our y, we want all the y values less than -3, so we're going to shade below. Now that we have our shading, we look at where the 2 shades cross. That's going to be your solution set. So again, any point in this region, if you were to plug that into this system for x and y, it would make both inequalities come out true. And again, because this line is solid, that's part of your solution set. So any point on this line would cause this inequality to be true. But since this line is dashed, you could not pick any point on this line because that would cause one of these inequalities to not be true.
Which animal is best at hitting a baseball? A bat! Boom, boom, boom! You try!
Okay, doing the same thing. Let's plot our first one. X is less than or equal to -1. So we start. Is it in slope-intercept form? No, it doesn't need to be. It's x equals a number. That's an equation of a vertical line. So when we plot our vertical line, we're going to use closed circles because there's an equal sign here, and we go to x equals -1, and we're going to put 3 points for the vertical line x equals -1. So how about at -1, 0, -1, 1, -1, 2. Got our 3 points. Next, we're going to decide solid or dashed line. There's an equal sign here, so it's going to be a solid line going through those 3 points. And then we decide, are we shading to the right or left? Well, we look up here, we want all x values less than or equal to -1. So we want all the x values less than -1. So we're going to shade to the left of our given line. That means any point in this region and on this line would cause this inequality to be true. Next, we have y is greater than 4. So again, since this was the equation of a vertical line, x equals a number, y equals a number is going to be the equation of a horizontal line. So is this in slope-intercept form? Y equals mx plus b. Yeah, there's just no x, so we're in slope-intercept form. Next, let's plot 3 points. So this is the equation of a horizontal line at y equals 4. Because there's no equal sign here, we're going to put open circles for that horizontal line. And again, you could put them anywhere on this horizontal line, y equals 4. So at 0, 4, I'm going to put an open circle at 1, 4 and 2, 4. Got my 3 points. Next, solid or dashed line. Since there's no equal sign down here, I'm going to put a dashed line going through those 3 points. And then do I shade above or below this given line? Well, since it's a inequality symbol that is eating your y, you want all the y values greater than 4. So you're going to shade above that given dashed line. Now you can see your 2 shades cross in this purple region right here. That would be your solution set. So again, any point in this region, if you were to plug that into this system for x and y, it would make both inequalities come out true. And again, you could pick any point on this line as well, but not on this line because this one is dashed, this one is solid. Example 5, doing the exact same thing. So we're going to graph the solution set to this system. Now, we start with our first linear inequality, x is greater than or equal to 0. Again, we have x equals a number, so that's not necessarily in slope-intercept form, but that's okay. We know what this is. This is the equation of a vertical line, and that vertical line is going to be at x is equal to 0. It's going to be the y-axis. So what I'm going to do when I plot those 3 points, since there's an equal sign here, they're going to be all closed points. And when you plot those closed points, we start at 0, 0, sure, and then 0, 1, and then 0, 2. Got our 3 points. Next, we need to decide, are we going to have a solid or a dashed line? Since there's an equal sign here, we're going to put a solid line going through those 3 points. And then we decide, are we shading to the right or left? Well, since we have x is greater than or equal to 0, we want all the x values greater than or equal to 0. So all the x values greater than 0 would be to the right of this given line. So that's where you shade. Next, we're going to graph y is greater than or equal to 0. Now, is this in slope-intercept form? Well, technically, yeah. Y equals mx plus b. It's just there's no m or x. It's just a b. Cool. We're in slope-intercept form. Then we're going to plot 3 points. Well, what is the equation of the line y equals 0? Well, that's a horizontal line at y equals 0. So when we plot 3 points, we just need to pick 3 points on the horizontal line y equals 0, which is just basically the x-axis. So we pick 3 points on that horizontal line, and notice that they're closed points because we have an equal sign down here. So we have our 3 points. We then draw a solid or dashed line. Well, since there's an equal sign, again, that means we put closed points. That means we're going to have a solid line going through those 3 points. Lastly, are we going to shade above or below that given line? Well, since we want all the y values greater than or equal to 0, we want all the y values above that given line. All the y values greater than or equal to 0. Sweet. Now we see where those 2 shades cross. That would be the solution set for these 2 linear inequalities. But there's one more linear inequality in your system. So we need to graph this on the same coordinate plane. So let's do that. We first decide, is this in slope-intercept form? Y equals mx plus b. Yes, it's in slope-intercept form. After that, we're going to plot 3 points, and they're going to be open circles when we plot them because there's no equal sign here. So we first plot our y-intercept, which in this case is 9, so we go up to 0, 9, and we're going to put an open circle. Then we're going to use the slope to get the rest of the line. Since our slope is -2, we write that as a fraction, -2 over 1. That's our rise over run. So we go down 2, 1, 2, right 1, put an open circle. Down 1, 2, right 1, put an open circle. Then, after we plotted our 3 points, we decide, do we have a solid or dashed line going through those 3 points? Well, because there's no equal sign here, that's why we put open circles. There's going to be a dashed line going through those 3 points. That means that no point on this line is part of your solution set. After that, we decide, are we shading above or below this given line? Well, since the inequality symbol is facing away from the y value, that means we want all y values less than our given line. So we want all the y values below our given line. So we shade that way. Now, where all the 3 shades cross, that is your solution set to this system. So that would be this triangle in here. That is your solution set. So any point you pick in this shaded region, this shaded right triangle right here, that would be a solution to this system. That would cause each of these linear inequalities to come out true. Again, because this is a solid line and this is a solid line. Any point on this line or this line would be part of your solution set to this system of inequalities. Any point on this dashed line, however, would not be part of your solution set. Because it's a dashed line, that means it's not included in your solution set to your system of linear inequalities.
Why did the batter go to a car dealership? Because he wanted a sales pitch. You try.
Okay, doing the same thing here. We'll start with x is greater than or equal to -1. So again, is this in slope-intercept form? Not really, but that's okay. We know that this is the equation of a vertical line, right? X equals a number. And when we plot that vertical line, we're going to put closed circles because there's an equal sign down here. And we're going to go over to x equals -1 and put a vertical line, just 3 points on that vertical line. Next, is it going to be a solid or dashed line? Since there's an equal sign down here, it's going to be a solid line going through those 3 points. That's why we put closed circles. And then last but not least, do we shade to the right or left? Well, since we want x values greater than or equal to -1, we want all the x values that are greater than -1, which would be to the right of our given line. Next, we're going to graph y is less than 8. So is this in slope-intercept form? Technically, yeah, it's y and then mx plus b. There is no m or x. There's just a b value. Okay, we're in slope-intercept form. Because we knew this was a vertical line, x is equal to -1. We know y equals 8 must be a horizontal line. So we're going to graph a horizontal line at y equals 8 and then shade. So when we plot our 3 points, we said we're going to graph a horizontal line at y is equal to 8. So that's going to be right about here. You pick 3 points on that horizontal line. Doesn't really matter where. Since there's no equal sign down here, we're going to put open circles. So I put an open circle here, here, and here. Sweet. Got my 3 points. Next, I'm going to decide, is this going to be a solid or dashed line? Since there's no equal sign, that's why we put open circles. That's also why we're going to put a dashed line going through those 3 points. Last but not least, do we shade above or below? Well, since we want all y's less than 8, we want all y values less than 8. So below this given line. Any point in this purple region would be a solution to either of these inequalities. However, our system has 3 linear inequalities, so we need to graph this one on our coordinate plane as well. So let's do that. So is this in slope-intercept form? Y equals mx plus b. Yes, it's in slope-intercept form. Next, can we plot 3 points? Yeah, we'll start with our y-intercept, which in this case is -8. So we go down to 0, -8. And since we have an equal sign here, we're going to put a closed circle at 0, -8. We then use our slope to get the rest of the line. Our slope is 3. We write that as a fraction 3 over 1. So that's our rise over run. We go up 1, 2, 3, right 1, put a point. Up 1, 2, 3, right 1, put a point. Sweet, we have our 3 points. We then decide, is this going to be a solid or dashed line? Well, since there's an equal sign here, and that's the reason we used closed circles, we're going to put a solid line going through these points. That means any point on this line would be part of our solution set. Last but not least, do we shade above or below our given line? Well, since our inequality symbol is eating our y, we want all the y values greater than our line. So we will shade above our given line. In this region where the 3 shades cross, that's going to be your solution set. That means any point in this region, if you're to plug them into any of these linear inequalities within our system, would cause the linear inequality to be true. Also, note that the lines, the solid lines, any point on those solid lines would be solutions to your given system, but the points on the dashed line would not be a solution to your given system. Okay, now our word problem says for Halloween you decide that you need at least 12 pounds of candy. Snickers cost $2 a pound and M&Ms cost $3 a pound. You have $48 to spend. Write a system and graph the possible combinations of Snickers and M&Ms that you can buy. So word problem. Step 1, we're not scared. We can do this. Don't give up. Step 2, what is the question asking? It's asking us to write a system and graph the possible combinations of Snickers and M&Ms that you can buy. Okay, cool. We can use that when we move to step 3, which is to define our variables. So if we're trying to find the possible combinations of Snickers and M&Ms, that would be the possible combinations of pounds of Snickers and pounds of M&Ms. So we'll say that, I don't know, X is the pounds of Snickers and Y is going to be the pounds of M&Ms. Now we can move to our next step, which is to write our inequalities. So what's our first inequality? In the problem, it says that you decide you need at least 12 pounds of candy. So if the only candy that we're buying are pounds of Snickers and pounds of M&Ms, then those added together must be at least 12 pounds. So X plus Y has to be at least 12 pounds. That means it could be more than 12 pounds, but at the very least, it must be 12 pounds. So we say X plus Y has to be greater than or equal to 12 pounds. The next inequality, well, what does it say in the problem? It says Snickers cost $2 a pound and M&Ms cost $3 a pound, and you have $48 to spend. Well, if Snickers cost $2 a pound, that means that 2 times X would give you the amount of money that you spend on Snickers. And then 3 times Y then, since M&Ms cost $3 a pound, would give you the amount of money you spend on M&Ms. And if you add those together, that must be less than the amount of money that you have. You can't spend more money than you have. So we have 2 times x plus 3 times y has to be less than or equal to $48. Cool. We now have a system of linear inequalities that we can solve by graphing. Notice that we only have the first quadrant. That's because you assume that you can't have negative pounds of Snickers and negative pounds of M&Ms. So we're going to graph both of them on this coordinate plane and figure out where our solution set is. So let's graph our first one. Here we have x plus y is greater than or equal to 12. How do we graph that? We start by putting it in slope-intercept form. So we're going to take this x, move it to the other side. Since it's positive x, we subtract x from both sides. And we write this as y is greater than or equal to, and instead of 12 minus x, we're going to put the negative x first and then add 12. That way it's in slope-intercept form. Next, we plot 3 points. So we start with our y-intercept, which is 12. So we go up to 0, 12. And since there's an equal sign down here, we're going to put closed circles. So a closed circle there. And then what's our slope? We're going to use our slope to get the rest of the line. That's -1. We write that as a fraction -1 over 1. That's our rise over run. So we go down 1, right 1, put a point. Down 1, right 1, put a point. So we got 3 points. We can then graph our line going through these 3 points. Is it going to be solid or dashed? That would be solid because we have an equal sign down here. So we draw a solid line going through those 3 points. And then we decide, are we going to shade above or below this given line? Well, since our y is getting eaten by our inequality symbol, that means we want all y's greater than or equal to this given line. So we shade above our given line. Next, we graph our second linear inequality. We got to put it in slope-intercept form first. So to get y by itself, we first move this 2x to the other side by subtracting both sides by 2x. These then cancel each other out, and instead of writing 48 minus 2x, I'm going to write the negative 2x first and then add 48. That way it's going to be in slope-intercept form, y equals mx plus b. Now to get the y by itself, I divide both sides by 3. I divide everything over here by 3. And these 3's are going to cancel each other out. This becomes negative 2/3 x, and this becomes 48 divided by 3 is 16. So we are now in slope-intercept form. We can then graph this line using 3 points first. So what is our y-intercept? That's the first point that we graph. That would be 16. So we go up to 16, put a closed circle because there's an equal sign, and then we use our slope to get the rest of the line. So it's negative 2/3. That means we go down 2, right, 1, 2, 3, put a point. Down 2, right, 1, 2, 3, put a point. Sweet. Now, is it going to be a solid or dashed line going through those 3 points? Since there's an equal sign, we put a solid line going through those 3 points. And then we have to decide, are we going to shade above or below that given red line? Well, since our inequality symbol is facing away from the y, we're going to shade below that given red line. And now you can see where these 2 shades cross. That is going to be your solution set. That means any point in this region would be a solution to this system of linear inequalities. What that means is that you could pick any point in here. Let's say 6, 10. What does that mean? That means 6 pounds of Snickers and 10 pounds of M&Ms would satisfy your linear inequality. That means you would get at least 12 pounds of candy and you would spend less than $48. That's what any point in this region and on these lines, because they're solid lines, would be a solution to your system of linear inequalities.